Okay, so in this video, we're going to discuss networking in VMware. Now, this is particularly important because we're going to be trying to consolidate as many virtual machines onto each host as possible, but we're going to need to make sure that those virtual machines have sufficient access to network bandwidth. It's not uncommon for physical servers to use network teaming to combine multiple interfaces together for better performance. So now that we're dividing those interfaces amongst multiple virtual machines, we might need to provide a pretty significant number of interfaces and balance them appropriately. And of course, we may have multiple networks that we need to connect to because we're hosting in different environments and presenting virtual machines in a centralized way to the various VLANs and so on that exist on your network, mixing even internet and internal traffic and other private traffic by isolating it using VLANs and maybe virtual firewalls. So for now, let's go take a look at the idea of virtual switches, network interfaces, port groups, and VM kernel ports. So I'm going to go ahead and just open the inventory, which is going to send me over to my host. I'm going to move down to networking. We've got a vSwitch created, a vSwitch 0. We've got a virtual machine port group called VM network. We have a VM kernel port, which represents a system network interface with an address called management network, and we can see that it's actually got two addresses. It's got an IPv4 address and an IPv6 address. We could turn that off if we want. We're using two physical adapters, vmnic0 and vmnic1. When we create virtual machines, those virtual machines will have their own virtual NICs. Those virtual NICs will be associated with a port group, and then that port group is associated potentially with one or more network adapters in order to connect them to an external network. We actually can run virtual switches and have port groups associated with those virtual switches that don't have any network interfaces. And in that case, the virtual machines that are connected to that port group can speak to each other, but they're not connected to the external network. Or maybe one of the virtual machines has two virtual NICs and one's connected to the internal private network and one's connected to an external network through a port group that does have NICs. And in that case, maybe through a proxy or firewall or something along those lines, that virtual machine will provide services to the other virtual machines for them to get internal or external access. When we start needing to configure all of these things, potentially that could require a large number of interfaces for the number of machines that we have and for the number of different networks that we need to connect to. At a certain point, it becomes difficult to support too many network adapters. We can go up to about 32 single 1 gigabit network adapters in VMware. We could also provide 10 gig interfaces, but you can actually only have 4 of those. Once again, that's going to limit potentially just how many networks we could connect to if we're just doing it using network cards. If we use VLANs and we actually extend the VLAN environment into VMware as if it was a switch, so we can have it participate in trunking with other switches and share their VLAN information, share their MAC address tables, share their VLAN configurations, and provide the ability to aggregate lots of different VLANs over the same NICs. This is really the way to achieve large scale, although it's going to require very specific configurations on our switches. Basically, you're going to configure it like it's another switch, so it has to participate in trunking and also has to participate in the VLAN protocol. There is a standard VLAN protocol, but lots of customers have implemented a protocol from their routing vendor. So in those cases, you may not be able to participate, or they might need to replace their VLAN protocol. That could be a little bit difficult to coordinate. And for environments in between, then potentially you'll just use the additional network interfaces. But for very large environments, that's something that's going to have to be looked at and considered. But of course, then that raises all sets of security questions and also questions about who manages it and so on. It's also quite interesting that you can actually install other virtual switches into VMware. So for example, the Cisco Nexus 1000 is the best known example of this, and it actually provides a full-scale Cisco IOS in a virtual switch that runs inside VMware, but all the protocols work and all the management tools work, and it can be managed by the people who manage Cisco devices in the way that they're used to doing it. So that can make things easier. Even though we're having overlap between administrative boundaries and even security boundaries, we can still keep those managed independently and make sure we have visibility into what's going on at each of the different layers. This is still going to be very important that everyone coordinates network, storage, and servers now in a way that we haven't needed to do previously. Now, potentially, I may want to add more network interfaces to that configuration to make it perform better or whatever, or maybe I need a different configuration for certain virtual machines. So let's take a look at the settings of what we have, and then we'll see how we could modify it to better meet our needs. So you'll see that we have the networking properties for the system up in the right-hand corner. And we also have the properties for, in this case, this vSwitch and everything that goes along with that vSwitch, including the network interfaces and the port groups and the VM kernel port. So I'm going to start with the system network properties. And if we go in there, you can see that basically we can turn off IPv6 and that's all you get. If you click add networking, that's a little bit different. And we're going to have the option to create a new virtual switch and or new port groups and so on. We'll take a look at that in a second. First, let's take a look at the properties of vSwitch 0. And here you can see that it actually represents not only the vSwitch properties, but we do have access to the port group properties and the VM kernel port. So virtual switches are effectively switches. They do almost everything typical Ethernet switches do. In certain ways, we need to treat them like switches, and we might need to set up things like trunking, but they don't do spanning tree and they don't do forwarding of any traffic. Anything that comes in on a physical interface is not going to get passed back out a different physical interface, which of course is what a switch would normally do. So only the traffic that's coming out of our virtual machines or going to our virtual machines or to the system addresses themselves is going to be allowed. But you can see what we've got here is a vSwitch with 120 ports by default. If we click edit, you'll notice that if we need more than 120 virtual NICs associated with that virtual switch, we're going to need to increase this number. You could decrease it, but you're really not losing a lot of memory for this, so I wouldn't worry about it too much. And you'll see we can boost this up to just over 4,000. Although you can do this, that number is actually shared across all the vSwitches on the system. So we can't have a dozen vSwitches that all have 2,000 ports each. That would get to be a fairly large environment. And I think at that point, you've probably exceeded the capacity of a single host anyway, and you can have some more vSwitches on your other hosts that are handling that workload. I'm going to go ahead and just leave this where it was. You can also change the TCP max transmission unit size. Shouldn't really be necessary to do this, but in some environments, if you're operating through firewalls or other network devices, gateways and things like that, potentially you may need to turn this down to accommodate some other type of protocol overhead. In some cases, what you actually want to do for VMware is turn your maximum transmission unit size up. In typical general TCP, then we should be using 1500 byte packets max. But we now have the ability to use what are called jumbo frames. And using jumbo frames, we can move our MTU up to as much as 9,000 bytes, which is going to mean less packets, larger packets, mind you, but less of them. And therefore, some of the TCP overhead for things like congestion control and so on is reduced. In iSCSI-based environments, for example, is going to be very popular. When we start looking at doing iSCSI and things like jumbo frames, we might be tempted to increase this, but we need to make sure that that's not going to impact the virtual machines or the operations of the system and so on, and that the switch is configured appropriately for that, that the NICs are capable of doing it, and whatever it is on the other side that you're connecting to for your iSCSI targets also support it. If we click over to the security tab here, you'll see that by default, it's going to prevent virtual machines from operating in Ethernet promiscuous mode, where they'll pick up traffic for MAC addresses that are not theirs. We've also got MAC address changes and forged transmits where they use an address other than their own. Typically, you might say, well, there's no reason I would ever need to do any of those things, so I'm just going to turn all of that off. But what you'll find is that some types of applications, for example, the network load balancing in Windows, actually require you to do things like MAC address changes and forged transmits. So we could change it here. Not really appropriate to set it that way for everyone, right? Really only the machines that need it. What we can do is we can create a port group and override the switch settings at the port group level and then associate virtual machines with that port group. Go over to traffic shaping. We can also ensure that no one virtual machine can completely saturate the NIC. It can get difficult to divide one network interface or a few network interfaces among so many virtual machines. In order to make sure they all participate and behave a little better together, we might want to turn on the traffic shaping. There's various other quality of service and flow control features available elsewhere, so the traffic shaping is pretty basic. But what we could do is go ahead and enable it, and then we can set the average bandwidth that virtual machines will be allowed in kilobits per second, so we can allow them to send at a higher rate for a certain amount of traffic. And we can then set the burst size here of the number of kilobytes that they're going to be allowed to deliver at that peak bandwidth rate when there's extra bandwidth available. Now, this does a fair amount to limit the potential that a virtual machine is going to saturate your network, but it doesn't do anything to guarantee that a particular virtual machine will have access to the network resources that they need. In order to guarantee performance of the network, then we're going to have to look at some of the other settings for resource reservations and so on. And if we take a look at the NIC teaming options, we have quite a few things to look at here, and we're going to do that in a later video that describes how to set up highly available networking and highly performing network links for different types of configurations, for vMotion, for virtual machines, and also for HA and some of the other features that we have in VMware. We have some load balancing options where we can change how this whole process of dividing NICs across virtual machines will work. We'll talk about network failover detection and whether or not we should update switches whenever we move a virtual machine from one NIC to another. And we can also configure active and standby NICs here, or if you have NICs that are not connected, then we can move them into the list of unused adapters. And if we go over to network adapters, here's where we would do that. And you can see that we've got NIC 0 and NIC 1. And if I click add, we can go ahead and pick up those extra NICs that we didn't use during setup. And you can see I now have 4 NICs listed here, and they're all in active mode. So that gives us an idea as to the basic network setup. We're going to take a look in the later videos at some of those load balancing options that we talked about and fault tolerance options. Take a look at creating additional port groups and additional VM kernel ports.